Hello viewers, welcome to Emmanuel Maths Academy. So in the previous videos, we were able to look at the general method of differentiation, the general for power rule. We also looked at the sum and difference rule, the product rule, the quotient rule. So today we'll be dealing on chain rule. So chain rule method of differentiation. What this method does is that it helps you find our derivative, our differentiation by composition. Now look at what I mean. If you are given a function like y is equal to x power 4 plus 3x, you have to find the derivative of this. That's the dy dx. How do you go about this? You solve this using the general method, right? The general power rule, where you differentiate this and also differentiate this, right? Just the general method rule where we say that if you are given that x is equal to x power n, then our dy dx is what? N s power n minus 1, right? Now what about if you are given something like this? Maybe all this raised to power 2. How do you go about this? Or maybe probably you might need to separate this, then use binomial expansion to expand, right? Okay. What about raised to power 4 or even 5? What do? You do the same thing using binomial expansion, or you distribute them and expand them, right? And what about if you have this number to be so high that this is maybe 50? How do you go about this? Oh, you continue using binomial expansion, right? No. There must be a way. There must be a way to go about this. And the method you use in solving this kind of situation, this kind of problem, is what we call chain rule, right? So what we do in chain rule is that we express this using composition. Now look at what I mean. Now, if you are given this, right? If you are given something like this, and you say let u equal to this, just introduce your u. Let u equal to this whole thing that you have here, s raised to power 4 plus 3x. Then that means automatically your y is equal to what? U power 50. Something is going on here. We say let u be all these things that you have inside here, right? Then our y is equal to u raised to power 50. You can see that with this, you can actually differentiate this with respect to u, right? Now, if you have u to be equal to this, to find our du dx, now is let's find it here, somewhere here. Du dx is equal to 4a raised to power 3 plus 3. Then our dy du is what? Dy du is what? 50 u power what? 49. Is that correct? But remember, we are asked to find our dy dx. Is that correct? You are asked to find our dy dx, right? Now you have dy dx. Is there any way that we can express this dy dx to add something so that when you decide to remove whatever you add, you still have your dy dx? Can we introduce or multiply both sides, both the numerator and denominator, with du dx? No, not du dx, I mean du. If you decide to express dy dx as this, dy du times du dx, it's still the same thing, right? Because if you should cancel, you still have your dy dx, right? Are you seeing something? If you decide to cancel du, you still have your du, your dy dx, right? Now this is your chain rule. This is your chain rule, right? Because from here you have that your dy dx is equal to dy du. What's our dy du? We have our dy du here as what? 50 u power 49, right? Times, what's our du dx? You have our du dx as this, times 4s raised to the power 3 plus 3, right? Now recall that our u, because all this you have to express this as a function of x and not u. Now recall that our u is something, right? What's our u? Our u is this, plus 3x. Hence our dy dx is equal to what? 50 u s power 4 plus 3s power 49 dots. We can also put multiplication sign there. Dot 4x power 3 plus 3. As simple as that. As simple as that. Now this is your dy dx. Is that clear? Maybe let's solve more example on this for better understanding. Now example. Let's call the other one example 1. Example 2. If you are given that y is equal to what? Let's say s raised to power 6. Okay, 4s raised to power 6, right? Plus 2x minus 5 all power 4. You are asked to find the dy dx of this. Find the dy dx of this. Right? Now, we let u be what we have inside this bracket. Let u be this. We say let u equals 4s power 6 plus 2x minus 4. Then our du dx. Oh, automatically our du dx will now be what? Differentiating u with respect to x, right? You have that this is what? 6 times 4 will give you 24, right? 24 s power 5 plus 2. This will give you 0. If you differentiate this, so this is a constant to give you 0, right? Then our y is what? U raised to power 4. As simple as that. Our y is now u raised to power 4 because our u is this whole thing. Right now, differentiating y with respect to u, we have that our dy du is equal to what? U 4 times u. 4 times u raised to power 3. Is that correct? Yes. Now, the chain rule, dy dx is equal to what? Dy du dots or times du dx. This should be the u, sorry. Dy du. This is now equal to what? What's our dy du? Our dy du is this. 4u over 3 dots. Du dx. 24s over 5 plus 2. Right? This is now equal to 4. Recall that our u is this. Right? Our u is this. Let me clean up this. Well, let me leave this formula for chain rule. Then our dy dx is equal to what? 4. What's our u? 4s power 6 plus 2 x minus 5 dot 24 x power 5 plus 2. As simple as that. This is your du dx.